welcome to today's session from the Institution of Agricultural Engineers and its special interest group for engineering and food and drinks. I am the current chair of the group. My name is Daniel Heft. I am a food engineer by training. I studied in Germany, my undergraduate later in the UK in Reading, food technology. And we will have two speakers on today. First speaker up will be from Nottingham University, Professor Nik Watson, followed by Heena Sharma from the National Dairy Institute in India. And I will hand over to my moderator today, who is our CEO, Charlie Nicklin. Thank you very much.
Okay, thank you, Daniel. Hello, everybody. So if I introduce Nik, Nik's research is focused on data-driven in-process sensing to deliver sustainable, safe and productive food manufacturing systems. And he's led various funded projects and has extensive industry collaborative research experience. So Nik's presentation today is on optimizing and cleaning processes through data-driven sensing. What we'll do is we'll make use of the chat function at the bottom of the screen. So if you want to put any questions in there, we can get those questions asked at the end. So over to you, Nik.
Thanks, Charlie. Thanks for the introduction. And thanks, Daniel, for organising this. So yeah, as Charlie was saying, my kind of main research area is all within digital manufacturing, which, you know, some people still ask what this is, but it's the use of digital technologies within manufacturing. And my own career has been in the food and drink space. And as a researcher, I tend to be more at the applied end of the technology development spectrum. So working with industry partners to look at how we can get some of these technologies to work effectively in challenging production environments and addressing some of those challenges which are unique to the food and drink sector, which are generally around innovation cultures and capacity to innovate and to adopt new technologies and resources in terms of expertise. So I work with a variety of different sensors. My background has traditionally been ultrasonic sensing, but in the last few years we've also got expertise in optical sensing in my research team now, and that allows us to do some really interesting stuff where we combine these different sensing technologies. Do lots with machine learning and predictive analytics, and that, as Charlie was saying, the application is really around sustainability, safety and productivity, and we're interested as well in appropriate technologies for SMEs. What I'm going to talk a bit about today is just a little bit of overview of digital manufacturing and data-driven sensing, that should say, not data-driven. Majority of my talk, I'll focus on a project we've been working on for probably about 4 or 5 years now with a variety of industry partners and other universities in the UK and abroad. And this is clean in place CIP monitoring. Then if we have some time, I'll put some slides at the end on another project which is tracking allergens in different production environments. So I'll talk a bit about that, but we'll see how I get on with time. So yeah, so just a bit about digital manufacturing. So in the UK, we have initiative, the industrial strategy, that's based around 4 challenges. One of those is cleaner growth. One of those is future electric vehicles. One's aging population, and one's AI data. And I think what's really interesting, these are the 4 areas that the government has said strategically they want to invest in, and then there's been a new report update on it just out over the last couple of months. And all of those are linked to food. You maybe think, well, electric propulsion, but actually we've got to, once we made this food, transport it across the country or even export it, so it is relevant. Within the space of digital manufacturing, the main area of focus there is around a challenge called Manufacturing Made Smarter, which some of you might have seen. And within that, they kind of focused on what they call 5 enabling IDTs, which is industrial digital technologies. Starting on the left, we've got additive manufacturing. That's your 3D printing. Lots of examples always hit the headlines in the food space. There, robotics and automation, we're all aware of. Virtual reality, augmented reality. Lots of areas there. Industrial Internet of Things, and this is really about devices connected to the internet. And these devices can be sensors that can collect data about your processes. So you can have IoT devices that are just simple temperature loggers. So as you're looking at products across the cold chain, you can actually monitor that temperature and make sure there's not been anywhere it's gone too hard. And the top one is AI, artificial intelligence, machine learning and data analytics. And actually, I've circled these two, one because they're kind of my area of interest, but also I think they're the ones that I like to have the biggest impact on the food and drink sector. The reason I think they'll have the biggest impact is because they're easier to adopt. It's much easier putting a camera or in a factory or attaching a small sensor to the outside of a vessel than it is installing a whole automated robotic line system. It's cheaper, it's easy to do, and it provides information straight away that allows you to make decisions. So I think these are the two technologies, and they work well together. You use the Internet of Things with your sensors to collect the data, and we can stream it back to the cloud. So we have lots of sensors with some of our industrial partners, and we're taking the data, and that goes straight back to our lab where we can do the analysis. And the analysis techniques of the AI and the machine learning. And although this is my thoughts, it's also backed up. If you look at there's reports that come out every year in some of the industry sector magazines about what are people invested in automation, digital technologies, and it's always around the sensors first, because it gives you that insight. It allows you to understand where you're maybe not working as efficiently as you should be, things like that. So as I just said, as we all know about the food and drink sector, it's characterised high volume, low value products, very different investment models and timeframes. So some of my colleagues who work in the other manufacturing sectors like aerospace and automotive, when they think about timeframes and for investment in innovation and research, they're talking about years and decades, whereas in the food sector, I kind of feel like long term for us is next week. Many SMEs in the sector, lots of legacy equipment. And the other thing to remember about the food sector, we're dealing highly variable biological materials. So hygiene is an issue, food safety is an issue. Safety is always an issue within manufacturing, but that's safety for the consumers as well as the people working in there. And we still have many manual operations. I mean, there is a big drive for more robotics, but we need things like soft grippers, we need adaptive robots, cobots that can work with humans. Just a little bit about sensors and machine learning. I appreciate you might not be able to see the top. I've got this thing. We'll move it away. So you'll hear people talk a lot about AI, machine learning, deep learning, all these things. And I think it's worth just kind of unpicking that a bit. Artificial intelligence, generally, before you define that, you need to define what intelligence is. And within this, we look at it as the ability to make a decision, provide some actionable information that allows you to understand something about your process or your product, make a decision. Machine learning is a subset of that, and the majority of the time when people say, oh, it's an AI, or if you watch an advert on TV and it's all new AI, it's really meaning machine learning. And what that's about is collecting a lot of data and then applying algorithms to understand what's going on. So an example on another project, we're looking at the quality and the texture of biscuits. So we will have a sensor system, and we develop, we make a load of really good biscuits, really bad ones, and then we put them through the sensor. So we've got sensor data, good biscuits and bad biscuits, and we can feed them into these machine learning algorithms because we put the data in and we tell it which ones are good and which ones are bad. Then it can understand which features in the data are important. It can build these models, and then it can make the predictions. Another subset which gets most of the interest these days is deep learning, and the main applications here are speech processing, natural language processing, so these translations, Google Translate, things like that, image processing as well. And deep learning is really just one type of machine learning, and it's very complicated, not complicated, it's very big neural networks with multiple layers, so multi-layer perceptrons there. And the reason that's getting a lot of use now, these technologies were actually developed several decades ago, but where they didn't have the right algorithms to effectively train them, and they've been developed, but also they're very data hungry. You need lots and lots of data for deep learning, and that was a challenge. But now we can put devices everywhere connected to the internet. We can get these huge data sets really quickly, and I think this is why the food sector it has a massive opportunity to benefit from these technologies. If you think of an aeroplane factory, how many airplanes do they make a day? If you think of a bakery, or how many loaves of bread do they make a day? It's a lot more. You can collect a lot more data really quickly, but there is some challenges we'll talk about. In terms of the sensors, sensors must be cost effective, must work continuously in production environments. We're involved in projects looking at the kind of barriers to adoption with Loughborough University, their business school, and the academics there. And the companies tend to not have the expertise. So anything they deploy must work first time every time, must be connected, because then you can have that expertise off-site checking everything And this term you've probably heard me say a few times already, actionable information. There's a drive now just to collect data on absolutely everything, and that's fine, but it's going to cost you a lot of money. Really, you need to start with what is it you want to know about your processes? What is it you're trying to do? What are the opportunities and the challenges? Then work back and collect the data that you can analyze to allow you to make a decision. Without a doubt, the most common sensors are optical sensors, and this could be imaging in the visual range of a simple camera. It could be spectroscopic, so near infrared, ultraviolet are wavelength ranges, which gets a lot of interest to. Ultrasonic and acoustic, not used as much, but the kind of advantage there is optical, you can only see what's going on at the surface. Ultrasound, you can start moving through the material, similar to ultrasound imaging being used. X-ray used a lot for like foreign body detection in foods, metal, for example, and packaging, things like that. But you can get more information out of that. And the final area, which is the growing area as well, is electrical techniques and dielectric microwave terahertz. And just a few points on the challenge of AI. The models are only ever, or machine learning, I should say, the models are only as good as the data you collect. Data collection and labeling is expensive. If we just think about, going back to my example of good and bad quality biscuits, if we were to work with a manufacturer, we could put our sensor online, all the biscuits are going through, collecting the data is easy. But what we need is someone to sit and check every single biscuit and go, was that good or was that bad? Now, for some of these deep learning techniques, you want to be using tens of thousands, hundreds of thousands of data points to train a really good model. So that's tens of thousands, hundreds of thousands of biscuits. So measuring the sensor takes no time, instantaneous. But having someone check every biscuit and label it as good or bad, that's one of the challenges. And I'll talk about some of the approaches we've done to overfit. And some general challenges you always get with these types of modeling is overfitting, generalization. And these are issues around it fitting well to the data you're training with, but then when you apply it to new data before they use training, it creates an issue. And lots around explainability, interpretability, and trustworthiness, because these are predicted algorithms. If a machine learning algorithm says that pipe's clean, so it's safe to use, and it's not, whose fault is that? Yeah. Just to have to speed up a bit, but just a bit to, if you're going to use data-driven sensing, so combining machine learning and in-process sensing, it's really important to, I think when we focus on Industry 4 or automation, we think about the technologies, but the key enablers really is the people. And in my experience, in a food factory, people understand the materials and they understand the process. Now, if you want to start adding these, you need people who understand the sensors and the data. Sensor companies still usually work on the business model of, we want to sell you some hardware. Once you've got it, it's up to you. They will help you a bit, and they may have integration aspects. But if you want to use data-driven sensing, you need to know how to collect the data in your own factory, your own system, with the sensor, test it, and that's often the challenge. Some sensor companies do have data scientists. Some of the larger food manufacturers have their own data scientists now. But I find for these things to work, you need that expertise, and it goes without saying, like the majority of projects, it's important to have a champion's engagement across all job families. So the people who will be working in the factory, as well as the people who are in the boardroom. This is just the kind of process we follow. We've got a publication under review on this, looking at a methodology for combining sensors and machine learning. This was specifically for efficient resource use, so sustainability. And the three areas are the actual application, the sensor part, and the machine learning part. So your resource efficiency problem might be reduce the water and energy in a CIP, cleaning place process. So you need to determine what it is you want to find out. So you want to find out how much water is used, how much energy is used. So you want to know how long is your process going on, what's the conditions there. You then need to determine which sensor to use. So you have a sensor selection, then you need to decide how to collect the data and label it if you're using these supervised machine learning. This is a standard machine learning process. So you design your models, so you select the models, so it could be a neural network, spot vector machine, random forest, there's lots to choose from. And as I said, deep learning tends to be the one people are doing the most research on now. There's your feature engineering, so your sensor, if it's a camera, will record an image. If it's an ultrasonic sensor, it will record a sound wave. You've got to take that sensor signal and extract some features which you feed into it. You can feed in the whole of it, the whole image. But often there's problems if you have too many features relative to the amount of data you get. So you tend to do a feature engineering or data reduction stage. Train your model, evaluate the model on the training data set, validation set, and then you'll adjust some of the hyperparameters in the model. So, for example, numbers of layers in a network, things like that, number of trees in a decision tree. Then you test your model. It's really important that you test this on data that was not used in the training and validation. So it's independent. And ultimately, you need to determine, does your sensor model actually go back and give you information on that? And if not, that's where you have to look at it again. So that's a bit of a methodology. There's lots, the machine learning methodology is very common, but what we've done is adapted it to include the in-process sensor part. Looking at time, I'll probably just focus on this first case study, the clean in place monitoring. So clean in place is it's like your dishwasher at home, but in a factory much bigger. So in dairy, one of the biggest problems is if you're processing the milk at a high temperature, the UHT, you will get this fouling burning onto the equipment, and you need to clean it. And the CIP process is someone will press a button, it'll be automated, and it'll have several stages, and like similar to a dishwasher. Send water through to rinse off any of the loose soiling or fouling. Then it'll have a chemical phase, so caustic, sometimes there's the acid and alkaline phase there, sometimes at high temperature, sometimes it's very high flow rates, turbulence there. And then what you hope is, well, you'll develop this, you've got lots of variables you can play around with, temperature, time, flow rates, chemical composition, volume, things like that. Yep, so you'll design your CIP system and you'll validate it, and then you run it the same. Now, what you hope is every time you use it, it's always clean. Now, when this is like your dishwasher at home. Every time you open your dishwasher, your plates and your cups are clean, which is what you want. But then usually they weren't just clean at the time you open; they were probably clean for a long time before then, which means you've actually been paying for energy, for water, for chemicals to clean something that's already clean, and that's bad for you in your home and for the environment. But imagine that on the scale of a food factory. And there's some references there, which are a bit old now, but it's saying 30% of energy in dairy process spent on cleaning. So if you think of the scale of that, it's a lot. So we've been working on the project for several years now with some industrial partners, University of Loughborough, looking at applying sensors and machine learning. So we kind of say a food factory is either tanks or pipes, and your pipe could be food heat exchanger. So we've been putting ultrasonic sensors on the pipe. The guys at Loughborough have been putting ultraviolet fluorescence sensors on tanks. But I'm going to focus on our bit, which is the ultrasound. This is Pepe, one of our previous researchers, doing some work with one of our partners there. So very small sensors we're just putting on the bottom of a tank there. So how does the ultrasound work? Well, it's a non-invasive sensor. We put the transducer on the pipe wall. The orangey brown colour is the fouling. The sound wave goes through the wall, reflects from this interface, that the sound wave travels through, reflects, and the way it reflects is dependent on what's on the interface. So if there's fouling on there, it affects that reflected signal. And this is what we get. So this is the received sound wave. This blue part we don't use, and this is the bits coming back. So it's quite a messy signal because the sound wave's often still transmitting as it's being received. But we know it changes. So within our models, what we're doing is developing binary classification. So this goes back to what I was saying. What's the actual information? Is that pipe clean or dirty? We don't need to know. We've done some further work on how dirty is it, but to start with is there fouling on there, yes or no? Because if you know the fouling's been removed, you can stop the process. As this is a point measurement, you have multiple transducers across your equipment. We've looked at, so it's a binary classification model. Is it clean, yes or no? And with machine learning, you can have classification models which give you an output in a class. Is it a dog? Is it a cat? Is it good quality biscuit, bad quality? Or you can have regression where it predicts a numerical value, which would be how much fouling. We've got different feature engineering methods. In this one, we did a k-best features to select the points on the waveform, but we've tried lots of different methods here. We tried different fouling materials. So we did initial work, was on a small lab scale rig. We've got the pilot rig, and we're doing tests with partners. So we looked at 3 different types of fouling. So we didn't do any burns on dairy, I'm afraid, but we did look at tomato paste, gravy, malt, and different cleaning temperatures. Now, this is it's not the most exciting video, but what we've got on the bottom is a plate there. This is our fouling material. Underneath, where you can't see, we have our ultrasonic transducer. We have a camera now. The reason we need the camera is, it goes back to something I was saying earlier, because we're using supervised machine learning, we need to know, to train the model, we need to know when was it clean and when was it dirty. If every ultrasonic wave, we need to label that clean or dirty. And how we do that is with a camera. Now, the clever ones will be, well, why do you need this ultrasound sensor? Just use a camera. Well, the reason is because unfortunately not all food factories use clear perspex pipes. And once we've developed this model, we've now got some new ideas of how we can actually apply that model in an industrial setting. So I'll just play the video because we've got it, and we can just see, yeah, over time the fouling removes. And that's tomato paste. That tends to just dissolve into water, move along. Gravy and the mold, they clean very differently. But our purpose of our research isn't to study the cleaning behaviour, the fouling behaviour. It's just to work on the sensor side. Now, here are some results, and this is classification results. So from the images, when it's orange, so the transducer is on the back side of that plate. When it's orange, it means it's dirty, and when it's blue, it's green. So that's our ground truth. Sorry, yeah, it's clean. That's our ground truth data. And the transducer is on the other side of the plate, and the footprint of the transducer is that circle. So every time there's some fouling or not some of the red or brown in there from the image, we say it's dirty, and then when it's clear, it's clean. And these are predictions from our model. So KNN is K nearest neighbour, SVM support vector machine, RF random forest. AdaBoost is a method that combines different models. Now what we can see here is this model and these bottom ones, they perform almost perfectly, 99%. This one doesn't. It keeps telling us it's dirty by saying it's orange, but it's actually clean. This is one of the issues with a lot of the basic machine learning techniques. They don't have this explainability. So we don't understand why it's having that problem. This is for gravy. And this is even worse because this is telling us our factory is clean when actually it's still dirty. We actually think we know what the problem was with the gravy. And that's because of the way the starch actually swells and it stays attached, but it moves around. So actually the bit under where the gravy is technically clean, but the gravy is still there. But this is a challenge for machine learning, and there's actually some work going on at the minute that we're involved in around explainable AI, which is really important, especially using it for safety applications like that. This is, I'll go through it super quick. It's just about how you design your data set. And for this, the main take-home message we want to show you is actually that more data is better. It always is with these machine learning approaches. So we combine data from tomato, gravy, and malt, 3 different fouling materials. But really, we can combine that data because the question is the same: is they found in there, yes or no? And we can get, if we just focus on this column, we can get model prediction accuracy up to 100. When we develop a model just on one of those, we can see our model accuracy is a lot lower. So again, you've probably heard this if you've ever been to any machine learning talk. The person with the most data wins, and this is an example of that. This is probably the second to last thing I'll focus on because I'm conscious we're running out of time. Is right, you've developed this model, but you're all going, how's that ever going to work in a factory? Because you need the labeled data, you need the images. Well, actually, you don't. There's a methodology here called transfer learning or domain adaptation, which is where you develop a model in one system, so our lab system, and you apply it to another system. So what you've got to do is you have to do some feature scaling. You have to understand how the differences. The other method you could use as well is semi-supervised learning, where you have some data from your industrial application. But we went around this transfer learning approach. I won't go through all this, but the main thing to note is we have a non-transfer learning where we actually did use the images, and we have these two methods, single feature and transport component analysis, where we don't have any labeled data and we want to see if it works. Lots of numbers, lots of words, but the take-home message here is these are our models trained the traditional way. This is the one using the single feature, and actually we've got very similar model accuracy. The data set 10, 98, 95. So we're really happy. And what this means, and this maybe just doesn't seem like a big result, but this is actually what needs to happen it's one of the barriers to using these technologies in an industrial environment, that labeling the data. And with this method, we don't need to do it. We can train a model in our lab and then apply it straight away to the factory. Because if you wanted to use these machine learning approaches the traditional way, you would have to put the sensor on, collect a lot of data for days, weeks, months before you can actually use the benefit of your model. You'd have to understand, do you need to change that for each formulation, each piece of equipment? With these methods, you don't. So they're really, really important within around. We're happy to have some work out in this area. Absolute last thing I'll talk about is regression models. So all the previous results were about predicting, is it dirty or is it clean? That's what we wanted. In this model, we wanted to know what is the volume of fouling and the surface coverage of fouling. And this was done with one of our collaborators, Alessandro Simeone from Shantou University in China. And they did some much more advanced image analysis, and they worked out the kind of volume of fouling from some of the images, and then they developed these models. And it's actually quite interesting because we initially thought the ultrasound was only really sensitive to the coverage on the transducer. So if you think of the transducer like this in the plate, only really the area that was covered that was affected, not the actual volume and amount. Whereas this shows us if you've got a changing volume, you will get a result, and we're getting training results. So this is just showing how good the fit is, and generally you want that kind of straight line, and 1 would be optimal, 0 would be the worst. We never hit 0, but so 0.9 again, we're really happy. We think this is to do with how the sound waves dance when there's more fouling on the surface. They're really interested if we would publish this. I'm not going to talk too much about this because of time, and I appreciate there's another speaker, but we did some of the work looking at allergens across the food chain. Totally different sense than infrared, but machine learning approaches. And really, again, with this, it was understanding what was the challenge. And it wasn't about looking at small percentages of allergens in materials. It was just identifying if you've got white powders, what are they? That's if you work with the food manufacturers, that's what their concern is, that someone just picks up the wrong material into a product. And what we found here was we had lots of white powders, nuts, gluten-free flours, gluten-containing flours, animal-based, other products. And just by extracting features from our infrared, we can see you do get a lot of crossover between the gluten-containing, gluten-free flours, and that's because there's other components within those materials. It's not just gluten, so you would expect them to have the same signatures, but the other ones were spread out, and these are some model results. Penultimate slide. So yeah, it's really important for all these technologies to engage with different stakeholders, technology developers, the producers, the academics, the regulators, the government bodies such as the FSA. So we're constantly doing workshops around how do you deploy technologies, how do we get trust in these systems. This was one we did in London. Well, I think this was late 2019 when we were still allowed to travel, all about this area of AI. And we've got a couple of reports on that. So just a summary there, the deployment of industrial digital technologies such as AI is expected to rise in food and drink due to the benefits they can deliver. But we need to embrace these technologies and innovate, but we need to understand the limitations and the barriers to adoption. Humans are absolutely key, and I think with some of the more complex sensing problems, as chemical and process engineers, we always want closed loop control systems and everything's doing it autonomously. But I think with some of these decisions, we need to keep the human in the loop as well. The sensor provides some information and says to the human, what do you think? You make the decision. Yeah, and to accelerate the adoption of these technologies, I think we need more trials in factories. So again, if it's been really difficult for us the last year because a lot of the time we can't get in the factories to do our trials with our partners, but we've got some methods how we can do this virtually. We send them the sensors. So if you are interested, you can get in touch with me via email. I'm happy to have a follow-up discussion. Right, that's the end of me. Yeah, just acknowledgements. Lots of people working on this. Lots of funders, Innovate UK, PSLC, STFC, Food Standards Agency. Lots of great researchers across Nottingham and other universities. I've been really fortunate to work with. So that's the end of me, Daniel. Charlie.
Thank you, Nick.
Sorry, I had to speed up a bit at the end there.
Okay. No, that's fine. I know we're a little bit tight for time. We have a couple of questions. Jahinda Momi has a question. Do you want to ask? Okay.
I just wanted to say, what type of processing power do you use to generate your models? And also, do you use cloud computing?
Yeah.
Imagine going into industry. You don't want to take a massive computer over. You want to somehow send it over to do the heavy lifting somewhere else.
Yeah, so I'm an engineer, so it's the data scientists in my team who do all the kind of technical bits. But absolutely, what we do with the sensors is we some of the boxes we've got, we just connect to the cloud, so all the data is just going back. You're absolutely right. I mean, the cleaning work we've done, we still sometimes take the laptop in and set it up, but we've got projects in like monitoring fermentation in craft breweries. And the biggest problem we had there was initially what we do is set the laptop up and just stream the data somewhere like Dropbox. so we could still see it coming in. But you'd find they'd spill beer on the laptop, they'd kick it, they'd unplug it because they want the extension cable for something else in the brewery that day. So yeah, now we've got systems where we can just put the sensors in, connect it, and just stream the data autonomously. Yeah, and some of the analysis on the cloud, some of it, I mean, our data sets aren't really big data from some of the applications. They're not huge high resolution images or something like that. So we've been fine just doing it on desktops. We've got a few of them use specific GPUs and stuff like that. But yeah, it's not been a big problem on that. If you do have any more technical questions, if you send me an email, I'll get one of the data team to follow up with you.
Yeah, okay, I'll send you an email.
Daniel, do you want to ask your questions?
Yeah, Nick, I'm getting excited. I have two questions. You mentioned you get away with fairly small training data sets. What do you consider small? Is it like?
I'm going to go back and look at it. So I think when you talk about the size of your training data set, it depends on the difficulty of the problem you're solving. And that actually, we've always been interested in kind of AI and machine learning, but the problem of is they fouling on a pipe, yes or no? If everything's at constant temperature, constant flow rate, you get such a big difference in the reflected signal. You don't really need machine learning. You just say, is the signal above a certain threshold value? If it is, it's clean. So we were like, actually, we've got a solution, but the problem's not quite right. But then we started messing around things with different fouling, different temperature. And what you see is that the signals jump all over the place. And that's where the machine learning comes in, because it doesn't go to an absolute value. It doesn't have the same gradient and inflections each time. In terms of the amount of data, I think, yeah, we had, I think, about 15 or 16 runs. I think each run was, you got a calculator there, each run was about 15 minutes.
I do. A good engineer always has this calculator.
So I think we had 15 runs, each one was 15 minutes, and I believe we were collecting a waveform every 4 seconds. So that's how much data. It's all in the publications that we sent out last year. It's got
I mean, I have your email anyway. If you send me a link later on.
Yeah. No
for the grading systems, did you look into things like fuzzy logic or?
No. We just looked at simple classifiers. I know there is quite a lot of work in this area in fuzzy, but we didn't go down that route. I mean, my background has mainly been on the sensor side, so we do a lot of the data processing side has been working with the computer scientists and data scientists. So yeah, I don't know. I mean, someone emailed us the other day with another new method that we should be looking into. Like, and there's all the kind of Bayesian methods which we're doing a bit more now because you've got that explainability. So we've been working with some guys in Liverpool, stuff in this space.
Well, thank you, Nick. I'll make space for the other question, Charlie. I can see Gary.
Yeah. We better move on to the next speaker. Thanks a lot for that, Nick.
Yeah, no problem, guys.
Okay, so I'd like to introduce Dr. Heena Sharma. Sorry. So I'd like to introduce. So Dr. Heena Sharma from the National Dairy Research Institute. So Dr. Sharma has been serving the Indian Council of Agricultural Research since 2016. She has expertise in livestock technology, meat and milk products. And she's recently focused her research area towards non-bovine milk and milk products, including goat and camel milk. Currently, she's involved in 4 projects as principal investigator and co-principal. 3 technologies of her research group have been approved for commercialization relating to goat milk-based cheese rolls, yogurts, and beverages. Dr. Sharma has done around 25 research papers and 6 review articles and 15 other articles in her work, and she's won several awards in national and international conferences. Okay, Dr. Sharma, do you want to begin your presentation?
Thank you, Charlie. I'll share the screen first. So, welcome to this topic, and first of all, I thank you, Daniel, for giving me this opportunity to speak here in front of all. And Charlie, thank you for the nice introduction. And the Institution of Agricultural Engineers, I'm thankful to you also for giving me this platform to interact with you all. So my topic here is processing of goat milk and goat milk products and overview. Before I start the topic, let me introduce the workplace. I belong to India and I am from the northernmost part of the country here, Haryana, that is a state, and we have this institute working focusedly on dairy products, mainly the milk and milk products, liquid milk also. We do the research on products also, cheese, ice cream, beverage, yogurts, everything. Then recently we have shifted our focus from cow and buffalo to non-bovine milk products, mainly goat, camel, yak also. We are procuring yak milk also from the hilly areas, and then camel milk also. So this is all about, I'm currently associated with the food technology lab, which is also working on some fruits and vegetables. We are procuring the products like jams and jellies. So mainly my work is focused on goat milk products, and here is the introduction about this. So yeah. So goat population. First of all, let me introduce about the world goat population. It is increasingly and it is growing continuously. You can see the uneven distribution of the goat population here. Mainly, it's concentrated in Asia, South America, and some parts of Africa. And here the density also, it's the same, almost the same case. In India, you see the higher density up to more than 250 heads per square kilometer. And if you go to Africa, then it's almost 20 to 50 heads per square kilometer. So the uneven distribution of goat might be because of the differences in the preferences of the milk, differences in the taste of the consumers, and the increasing consumer ability, spending ability, expenditure ability also. So if you see here, global dairy goat population by region, if you see by the increasing trend from 1960s to 2017, you will see the growth rate is increasing tremendously. So it is this graph mainly shows you the dairy goats, and the growth is almost from 2007 to 2012. If you see, the growth is almost 22% globally overall. And if you go to Asia, it's almost 19%, then Africa, and then Europe. And dairy Asia, it contributes most, around 52% of the population, goat milk population, dairy goat population, followed by Africa, that is 39%. Then if you see the goat milk production, it is again uneven distribution because of the population distribution. In the same way, we have highly concentrated goat milk production. Goat milk production here in the Asian regions, mainly India. Then we have Bangladesh, we have Pakistan here, and in certain regions of Africa. And if you see here, 53% of the goat milk production is contributed by mainly Asian regions, mainly India, Pakistan, and Bangladesh. And just a second. Yeah. And followed by Africa, that is 25%. And again, if you see here, the global goat population, 218 million heads, followed by the production, 18.7 million tons. And India, it contributes out of 218 million, we have 136 million goat heads in our country. And goat milk production, it stands around 6.2 million tons. So talking about the United Kingdom, 90,000 heads, merely a very small size of goat population here, with a production of just 34 million liters. So world growth milk rate, it increased from in the past decade, 2 decades, 33.8% is a massive increase in the world goat milk growth rate. But mainly the goat milk growth rate is concentrated in the Asian regions only. So if you see the species wise, the whole milk production, 82% is contributed by cattle, followed by buffaloes, and merely 22% is contributed by goats. And we will be discussing about this very small contribution of goats to the milk industry, how they are contributing. So this is the organization where I work, Indian Council of Agriculture Research. They have recently asked us to drive our focus mainly on this goat rearing, then goat farmers, because goat products, they are very costly, they fetch high price to the processors also, to the manufacturer also. So high demand for this goat and products, and they have the potential for good economic returns also. So talking about the goat milk product size, it has been increasing again tremendously, and it has been projected to be over $17 billion by 2025. And all in all, consumers want more and more goat milk products because of their higher therapeutic values, because of their medicinal properties. So many research articles you will see about the medicinal properties of the goat milk. They're associated with the dengue fever here. It's prevalent in Asian countries mainly. So the world demand for all the dairy products, it's projected to continue to rise as consumers, they are more wealthy. They can spend more price for the products for their diet and increase their consumption of animal products. So precise to the prices to the producers, actually they are expected to be 19% more high by 2027, or you can say that by the end of this decade. So this is how the distribution is, how the sector is distributed among the goat milk and milk products. So market dynamics, it suggests that it is divided into the 4 segments mainly by the product type, whether it is liquid, we are selling the liquid product, we are selling the products, or we are selling the dried products, dried milk products. Also by the sector, whether we are into the business, large scale business, we are into the laboratory researches, and then by region, what type of products the consumers need, or what type of products they demand, actually what type of diseases or illness goat milk is going to be going to cure that. And by the distribution channel. So actually goats, they are found mainly in all the countries, irrespective of the location. However, if the countries, those countries or those regions, they are connected with the well-built infrastructure and transportation system, so definitely the goat sector will be enhanced. That market will be improved. So this year goat milk powder market insights, if we see, it is estimated that the goat milk powder market will grow at a compounded annual growth rate of 9% by 2024, just within 2 to 3 years, and mainly in the dried milk products, because goat milk is having immense therapeutic properties. That is why now the infant milk based formulas are in the market. So hypermarkets and supermarkets, they are likely to remain as the dominant sellers of these goat milk powders. So now also we are having certain goat milk powders in the market because of its therapeutic properties. So if you see here the production capacity of the goats, dairy goats, they generally produce between 660 to 1800 liters of milk, and they are having the lactation period of 305 days. And the gestation period is just 5 months. On average, at least 2.7 liters of milk is produced per day. I'm talking about here in the Indian breeds. And if you go to the exotic breeds, Alpine breed, it is native of France, and it is having a peculiar Roman nose, and it produces around 3 to 4 gallons of milk per day. And another one is Anglo-Nubian. It is also a high yielder, but it is a dual purpose breed. We can use it for meat also, and we can use it for milk also. But Alpine, it is mainly a Milch breed. So here in India, we have Jamnapuri. Jamnapuri breed is having the highest fat content. We can procure the milk from this breed if we are going to prepare the high fat goat milk products. Then we have Beetle. Surti, it's a dual purpose breed, and Jakrana is also a dual purpose breed. And I talked about the Anglo-Nubian breed. Among the exotic breeds, Anglo-Nubian breed is having the highest fat content. Although it is a low milk producer breed, but it is having the highest fat content. So why now the realization has suddenly arisen among all the milk manufacturers, or you can say researchers of the developing countries? It is because of the largest increase in the goat milk production, because of the increase in demand day by day during the past 2 decades. And goat milk is very effective in the people, in case of the people who are afflicted with the milk protein allergies. You might have heard about the milk protein allergies because of some casein protein in the milk. People are not able to digest that cow milk or buffalo milk, you can say. So we can give them the goat milk. Goat milk is the best alternative for that. It's having better digestibility because of its smaller fat globules. It's just 3.64 microns, whereas in buffalo, you will have more than 4 microns, 4 to 4.5 microns in cow also. So it's having smaller fat globules which are easily absorbable and which are easily digested, and it is alkaline in nature. It's having high buffering capacity, so it does not resist the pH change. So not resisting the pH change will be helpful in the better absorption of the goat milk and its peptide contents. It's having therapeutic values in medicine and human nutrition. We'll see in the detail. And then lower alpha S casein content. This alpha S casein content is mainly responsible for the milk protein energy. It is also having higher oligosaccharide content, which is almost 10 times more than the cow milk. Higher oligosaccharide content will make your gut beneficial, means the microbes which will grow in the gut will be beneficial for the growth and development of the body. Then we have higher amount of nucleotides in goat milk, higher average mineralization level of goat milk micelles, skeletal mineralization occurs because of this, and NPN content is also higher. Then this is, I have just made the comparison between human, goat and cow milk, just to give you the brief overview of how the goat milk varies and how goat milk is having the close approximation to the human milk, why it is suitable for infants. So if you say energy is almost similar in all the three cases, lipids almost similar, but the main you will see here in the protein content, you will see alpha S1 casein is absent in human milk, which is also absent in goat milk. This is the very remarkable property of the goat milk. And in cow milk, if you see, it's 1.01%, which is high. Then you talk about the patients who are having the milk protein allergy. Then whey protein, again, 0.6, 0.4, and 0.6%, almost similar, but you go to the casein whey protein ratio. When you are when you are formulating the product for infants, you have to make the approximate composition with the human milk. So you have to just formulate the product according to the casein whey protein ratio, but the whey protein and the alpha S1 casein, lack of alpha S1 casein makes it best alternative for the human milk. So, and also linoleic and alpha linoleic acid, it is the ratio, it is almost 2.75, which is higher than at least cow milk, not similar to human milk, but it's higher than cow milk. So here, if you see the protein content, immunoglobulin content, you see how higher immunoglobulin content is there. Immunoglobulins are protective factors for our body. They provide immunity to the body. So it's definitely closer to the human milk rather than this cow milk. Then minor proteins, lactoferrin and lysozymes, these are also somewhat higher in goat milk. Then just the summary of this differentiation of human milk, goat milk, and cow milk. Alpha S1 casein, it's a major allergen. I have already mentioned that. And human goat milk, they are not having that. Cow milk, it's there. Alpha lactalbumin, it's a major whey protein in the human milk, which is required for the synthesis of the lactose in the infants. So that is why goat milk is having almost double the proportion of alpha lactalbumin as compared to the cow milk. Then fat globule size, it is lesser as compared to the cow milk again, which is good for infants or even the elderly, if you say. Then linoleic to alpha linoleic acid, we have ideal ratio for the development of brain and cognitive ability. Then oligosaccharides, again, it supports the growth of the beneficial bacteria in the gut. Then coming to the specifically to the goat milk lipids, average diameter is this, 97 to 99% free lipids are there. That means more easily absorbed, more easily digested. It lacks agglutinin. Agglutinin is the compound which is responsible for the clumping of or for the separation of the fat in the milk. If you keep the milk just keep it for standing for half an hour or maybe for 15 minutes, you will see a cream layer separates over the top of that milk. In the cow milk, in the buffalo milk, but you will not see it in the goat milk because it lacks agglutinin, which causes the clumping of the fat globules and made it to rise. So the lack of the agglutinin also, it is reported that goat milk is naturally homogenized. So usually when we process the products for homogenized products or we process the goat milk for any other product, we usually skip the homogenization step. It adds to the economy to the processing. Then, however, we have a major problem with the goat milk, that is that the goaty flavor. Goaty flavor is because of the presence of the higher amount of medium chain fatty acids, mainly the capric acid. And capric acid, this is from where the goat, scientific name of the goat is derived, capric hyricus. So capric acid, caproic acid, and caprylic acid, these are the main 3 acids, medium chain triglycerides, which are present in the goat milk, and these are responsible for the goaty flavor. So now the researchers, what we are trying to do is we are trying to minimize the goaty flavor so that we can provide the consumers the product with the normal flavor, acceptable flavor, but with beneficial properties, therapeutic properties. So here the level of minerals, if you see calcium phosphorus ratio, it's 1:1 here, 134 milligram percent and 121, which is required for the growth of the body, normal recommended ratio. And if you see the vitamins are also in the required ratio, recommended ratio, and which are required for the healthy development of the body. So coming to the physico-chemical properties of the goat milk, specific gravity, it does not, it is lesser as compared to the cow milk. And going to the pH, it is to the alkaline nature, which can be consumed easily. Acidity is also not that high. 0.11 to 0.18 is normal, so that we can keep it at room temperature without any spoilage for longer, not for longer time, of course, just for 1 to 2 hours, it won't develop the acidity. It is whiter than cow milk because cow milk is having a beta carotene, that is why it is yellow in color, whereas goat milk is white in color. So that is more appealing to the consumers. It is alkaline in nature, no problem for the stomach. Curd tension is also less as compared to the cow milk, and curd tension is it should be less in order to digest the proteins and the fats in the product. So overall, it is considered to be an interesting nutritive value product owing to its unique fatty acid composition and protein profile. Absence and lack of alpha-1 casein is boon for the patients who are afflicted with milk protein allergies. And because of the smaller size of fat globules, they are easily digested. It can be recommended for elderly and for newborns. Then consumption of goat milk, it reduces total cholesterol levels and LDL fractions because of the presence of medium chain triglycerides. So this is the one major advantage of that, and we had that disadvantage of goaty flavor. So we have to make a balance in between these two. So the therapeutic properties, if we talk about that, goat milk, it is the immense source of bioactive peptides, which are involved in antioxidant in nature, anti-inflammatory activity, ACE inhibitory activity, antihypertensive. You talk about any bioactive property, it will be there in the goat milk. So another thing is lower alpha-1 casein. It's having anti-allergic properties, higher conjugated linoleic acid, which leads to the anti-carcinogenic effect. Then we have small-sized casein micelles and fat globules, provides better digestibility. Higher oligosaccharides, microbiota modulation, beneficial microbes are there in your stomach. And mineral content, it leads to the better calcium absorption. However, after all these things, all the goody things about the goat milk, we still have some technological challenges which we face while processing the goat milk. First of all, if we are not having alpha-1 casein, it will not form the gel. When we want to prepare fermented products or we want to go with the cheese type product, it's very difficult to form the gel network in the goat milk because of the absence of alpha-1 casein. So this leads to the softer gel products. They have lower viscosity. Yogurt is having thick it is very thick in nature, but if you prepare it with goat yogurt, following the same protocol as in the cow milk, you will have the lower viscosity of the product. So under coagulation also, the gel from caprine milk with an equal casein content, it is not as firm as bovine milk. You do not vary the casein content, just the alpha-1 casein is absent, still you will not get a good gel with the goat milk. So goat milk yogurt, it is usually characterized by the weak gel, lack of firmness and consistency, and it is more prone to syneresis. Syneresis is the whey separation. There will be some water separation if you open the can of the yogurt, or if you open just the cup of the yogurt, you will see sometimes you will see a separation of water like thing. That is syneresis. It is very prone to that. Goat milk. Then relatively low flavor development occurs during the fermentation and high buffering capacity. Resistance in the pH, alteration in the pH, it affects the starter growth and acid production. It will not lead the proper fermentation to take place. That is why quality of goat milk product, it always remains a challenge for processors or researchers for us. So functional properties of goat milk proteins. If you see goat milk proteins, they have having a high hydration properties. They have water absorption, wettability, swelling, dispersion. They can do all the things, but still they are not forming a good gel as compared to the cow milk. We have protein-protein interactions. We have surface properties. Everything is there, emulsification, foaming properties. But still, we need to use some technological intervention so that we can have a good quality goat milk product. So these are the few techniques which we have followed in our lab also, and we have seen in the literature also. Certain physical modifications are there, certain enzymatic modifications are there. If you go with the physical modifications, you can go with the ultrafiltration technique. Ultrafiltration technique, it is nothing but there is a membrane, ultrafiltered membrane, retentate, permeate are separated. Retentate will have more of the casein, more of the protein content, and permeate will have more of the lactose content. So accordingly, you can use that and you can prepare the product. But enzymatic modifications, you can use certain enzymes. We have microbial transglutaminase. They are having GRAS status now, and they are generally recognized as safe. So we can use them in the foods. They are edible. And we have to just judge the amount, the enzymatic activity of the enzyme which we are adding, so that a proper amount is added. And it helps in the cross linking actually, which I told you that in because of the lack of the alpha casein, gel network is not formed, but because of this intervention, enzymatic intervention, we are able to form a good gel. So physical processes, it also includes thermal treatment, then high shear mixing, high pressure homogenization is also used sometimes. It has the positive influence for altering the casein structure is altered, the casein vessel size is altered, where protein structural modification is done, which leads to at least the stabilization of the protein and the fat emulsion, you can say. Then improves the functional and textural properties of the products, and we have applied it in the development of the goat milk dairy products. So coming to the functional dairy products, out of the goat milk, we can incorporate the prebiotics to promote the growth of probiotics. Then we can have the symbiotic products. We have recently launched one symbiotic yogurt, goat milk based symbiotic yogurt. They are using all these technological modifications, interventions, and then prebiotics and probiotics. So we have the trend for goat milk based beverages also here. They are traditionally prepared and consumed in usually various parts of the world. And the guava pulp is usually added. It acts as a prebiotic, which supports the growth of probiotic microorganisms, and hydrolyzed lactomannan is there. So it enhances the dietary fiber also in the product. So addition of guava jelly improved the sensory and nutritional characteristics of the goat milk fermented drink. And addition of oligofructose and inulin is also added in cheese ways, so that it maintains the probiotic viability. Besides, it will also improve the texture in terms of viscosity, rheology, and textural profile. So we still have a scope for addition of all these prebiotics, probiotics, enzymes in the goat milk, so that we can have the good and acceptable quality goat milk products. Besides these, we are also concentrating on preparing the herbal based goat milk beverages, because nowadays we have so many, like we have a chemophobia around the world. No chemicals in the food, no additives in the food, only natural things, only bioflavors, everything. So we have focused our research on this side also. So however, incorporation of herbs in the goat milk, it leads to the protein and polyphenol interaction. Although it leads, it's the same thing happens in the cow milk also, but in the goat milk, because of this protein and fatty acid, different protein and fatty acid composition, it leads to the renneting problem, it leads to the fermentation characteristics problem. And usually just the incorporation, if you are incorporating a herb in the form of juice, in the form of powder, it will coagulate. Goat milk will coagulate, and that creates the problem. That is the challenge for the researchers, how to get over with it. So color and flavor incompatibility also leads to the pungency in the flavor, pungency in the taste, and then bitterness also. So we have to remove all those things, and at the same time we have to see that we come up with the good tasty product. So these are the different works which have been done on the goat milk, improving the characteristics of goat milk yogurt. They have fortified it with the mangosteen rind. It's antioxidant. The extract has been prepared. Extract is usually added at the lower quantity, so there is not much problem, but still you have to go with the goat milk yogurt. You have to ferment it. You have to come up with the fermented product. Then quality characteristics and antioxidant activities of the goat milk yogurt with added jujube pulp. This is also an antioxidant. Then food safety control of halloumi type cheese. Halloumi type cheese is like a mozzarella cheese, which we use in pizza. And this halloumi type cheese employs ultrafiltration. That is why it is better to use the goat milk for this halloumi type cheese production. Then we have influence of using different proportions of cow and goat milk. We have tried this in our station also here at NDRI. Admixture of cow and goat milk and admixture of buffalo and goat milk, it really yields very good results in terms of cheese rolls. We have developed cheese rolls because due to the admixture of this buffalo and goat milk, they usually complement each other. Then we have different works on ice cream and commercially available. If I talk about the commercially available goat milk products, then we have liquid milk, not only in India, abroad also, but the cost of the goat milk, liquid goat milk, is way higher than cow milk. If we are getting in 140 rupees per 300 ml of goat milk, we will get just 23 rupees of 500 ml of cow milk. So you can see the price difference. So here also we have ghee out of goat milk because of this beneficial properties of the goat milk. Then we have chocolates in UK. Cost is there. There is no data on quantity. Then we have cheese. Cheese is available throughout the world. Goat milk cheese also. Usually the feta cheese is there. Feta cheese is softer as compared to the cheddar cheese. The challenge is to prepare the cheddar cheese out of goat milk, that is also with the 100% goat milk. Then we have goat milk powder. This goat milk powder, it is very common, but the main challenge comes with the technology of the drying. If you're doing it with the freeze drying, definitely all the nutritive properties, all the beneficial properties are retained in the goat milk powder. But if you're going with the spray drying, that is the problem. However, freeze drying, we cannot go on the industrial scale. So here comes the challenge to prepare the spray dried goat milk powder, how you will do. And you have to see the technology that you have to give it to the industry, how this can be produced. So besides food products, we have certain non-food products also. We have soaps, we have lotions, we have shampoos made of goat milk. So people are not only using it in the diet, but they are also using it topically so as to have the more of the nutrient. Then we have certain goat milk in vivo studies, how the validation of their therapeutic claims, whether it is really controlling the dengue fever, whether it is really increasing our platelet count. That is the main mechanism of action behind that control of dengue. So we can use all these, and we can have they have already worked on, people have already worked on, and we have worked on the goat milk based functional beverage, incorporating the herb. We have really got the good results, health effects. We have seen these are not my results, of course, and health effects we have observed were antioxidant. Then we have seen the immunomodulatory activity, we have seen the tumor necrosis factors, we have seen the interleukins, all yield really very good results. So goat milk, it has antioxidant effect, anti-atherogenic effects, balanced intestinal microflora, recovery of malnutrition. Then it modulates your immune system, it enhances your immune system, it improves your immunity against diseases. Then this is just how goat milk is useful even when you are having high fat diet. Usually people stop taking high fat diet after a certain age, but here I recommend to use goat milk regularly. And no matter if you take high fat diet, this is the mechanism of action, how your obesity will be still controlled. So here you can see goat milk is having polyphenols, fatty acids, capric, DHA, all the essential fatty acids. And it acts on adipose tissues, your skeletal muscles, on the liver. everywhere. Here in the adipose tissue, it will decrease the lipid content because of increase in the uncoupling protein. Then it will lead to increased lean mass. Then in the pancreas, it will decrease the islet size, and these are the main insulin secreting cells. So it will increase the glucose tolerance, no doubt. Then coming to the liver, if you see, it will decrease the infiltration of the fatty tissue, steatosis, that is steatosis, and decreasing the cholesterol and triacylglycerols. Again, the anti-inflammatory factors, mainly the TNF-alpha and they are usually decreased. These are anti-inflammatory factors, but these are the pro-inflammatory factors, TNF-alpha and all. But if you go with the IL-6 and IL-10, those are definitely increased in your immune system. So coming to the conclusion, it possesses immense potential for utilization as liquid milk or processed dairy products, and different products from goat milk they're considered as delicacy, but still we have to go with the technological interventions to produce that. So it adds cost to the processors also, to the buyers also. Owing to its unique protein and fatty acid profile and health benefits, it definitely gives an upper edge over to another bovine milks. And better digestibility, higher bioavailability of micronutrients, presence of viable lactic bacteria, and production of certain bioactive components. Definitely, these can also be enhanced when we convert the liquid goat milk to the fermented products. And if you see about the future scope, we can think about the growth characteristics of certain strains when we are talking about fermented products, because we have to see the growth characteristics of strains, how these can be isolated or how these can be grown into the medium food matrix or goat milk. Then bovine milk protein supplementation, I told you, a mixture of cow milk and buffalo milk, goat milk UF retentant, ultrafiltration, high shear processing, all these technological interventions can be incorporated. Then effect of this enzymatic modifications, transglutaminase mediated gelation, we can see. Incorporation of prebiotic substances on the viability of probiotic microorganisms. And then we have to see the validation, because this is how we can emphasize upon the importance of goat milk, or how we can convince the consumers, or we can make them aware about the importance of goat milk. Then packaging, definitely packaging cannot be the same as in case of cow milk because of its different compositions. So thank you. Over to Nik. Daniel, yeah.
Yeah, thank you, Heena. Charlie, are you having?
Thank you for that really, really interesting presentation. If I can pronounce it correctly, we have a question from Asaya Mwambo. It was to do with yields. How do we increase the yield of milk to that of a dairy cow?
Okay, increasing the yield of the goat is actually genetics. It is the genetic in nature that we can go with some crossbreeding programs. We had it in our country, and we can concentrate on the indigenous breeds, and crossbreeding programs definitely will lead to because of the genetics, different genetics of the exotic breeds and different genetics of the indigenous breeds. It will lead to at least we can reach up to the mid value, but not like the cow, because it's having the long lactation period and they are having more of the milk potential.
Okay, I get that clearly. Thank you.
And then the other question I've got is really how does the production costs compare between normal cow milk and goat's milk?
Sorry, can you repeat the question, please?
The production cost. So if you were producing milk from cattle, how does it compare cost-wise with producing milk from goats?
Oh, yeah. The goat milk, they are very costly. Goat milk is very costly as compared to cow milk because of definitely the decreased potential. We are getting a low amount of goat milk in the country, in the market. So definitely it will be of higher value. The lesser the availability, more the price.
And it's more profitable for the farmer.
Yeah, definitely it will be more profitable. Yeah.
Yeah, okay. And there's a question from Jacqueline Golla.
Yeah, thank you so much, Dr. Heena Sharma, for the presentation. Yeah, I just wanted to inquire especially on the high protein content that is from your presentation in the goat milk, which is in comparison to the human milk. Is it yeah. And
Yeah,
I want,
it is higher. It is higher.
yeah. So I wanted to know what are your recommendations, because like most families in Kenya, they will advise you to substitute the breast milk if, for example, you're breastfeeding with goat milk. What are your thoughts on this?
Yeah, you can feed it to infants, but by dilution, not as such. You cannot feed the infant goat milk as such, but you have to go with the dilution.
Okay, thank you.
Okay.
Okay.
Sorry, can I ask one question?
Yes. Okay.
Heena, how does the shelf life of goat milk compare to bovine milk? Because the higher fat content, does it go off faster or?
Okay, shelf life of the goat milk as compared to bovine milk. It's almost similar if you are keeping it at room temperature. But now the researches are going on that we are going to freeze this sample, and then we are going to thaw there are difference in the nutritive value after thawing of the goat milk as compared to the cow milk. There are definitely the differences in the nutritive composition, physico-chemical composition. But if you talk about the raw goat milk and raw cow milk, they are having the equal shelf life.
Okay, we better draw it to a close. We've run over a little bit. Thank you, Heena, and thank you, Nik, for the presentations. Do you want to introduce tomorrow's speakers, Daniel?
Yes, so tomorrow we will have our final day. We will have two speakers. The first speaker is actually on the call today. It's Professor Ulrich Müller from the Polytech University in Germany called Technische Hochschule Ostwestfalen-Lippe. And he will present a technology he came across many years ago called counter-stream injection. And he will show work he has done in the past on various beverage and creams and how that might translate into dairy applications. The second talk will be given by an old colleague of mine, Daniel von der Gablens, who is the CEO or managing director of IAgrE Engineering Limited in Germany, and he will give us insights into validation of dairy bottling plants or bottling plants in more general. Yes, so that's it from my end. Charlie?
Yep, okay. Thanks for everybody for joining. We better draw it to a close. Thank you. Bye-bye.